So it looks like I didn't get very far into the homework before I told you that I didn't think you would have to pick inconsistent, deep, independent, and dependent. So it's a good thing we talked about it. So here we're going to, we have two different options. I can solve both of them for y, or I can solve one of them and just start trying to find the answer, or I can do the elimination method. Any of these work. So the first thing I'm going to do is, oh, it's so fast, the elimination method. Let's do the substitution, since that is the most common way that most of you will be doing, since that's what the lesson did. So I'm going to take this one here, and I'm going to solve it for x, just because. So I'm going to add 5x or 5y to both sides. Oh, except that these are lines. So let's solve for y. That way it puts it in slope-intercept form, and that's the most consistent with what most of you will probably do. So negative 7x. Although in this case, since we're not graphing, it doesn't really matter, but I think most of you will try and do this way. So we'll do this. Okay, so we're going to subtract 7x from both sides, and I end up with, on the left-hand side, left negative 5y equals negative 7x plus 1. And then I need to continue solving by dividing everything by negative 5. Negative 5 divided by negative 5 is y. Negative 7 divided by negative 5. Negative divided by negative is positive, but I still end up with this improper fraction of 7/5 x. And then plus, positive 1 divided by negative 7, or negative 5, is negative 1/5. And that puts it in slope-intercept form. So that, I think, will be the way that most of you end up doing this problem. So we'll go ahead and do the next one, also in slope-intercept form. So I'm going to subtract 14x from both sides. Negative 14x. There we go. So on the left-hand side, I'm left with negative 10y. And on the right-hand side, negative 14x plus 5. Now to continue, I need to divide both sides by negative 10. Dividing the left-hand side by negative 10 leaves me with positive y. And remember, every single term has to be divided by that negative 10. So I end up with negative 14 divided by negative 10. Negative divided by negative is positive. So positive 14 over 10, and we'll simplify that in a minute, times x. And then I still have this 5. So positive divided by negative is negative, and that's 5 over 10. And now let's go ahead and simplify those. So I'm going to copy and paste this down just because that makes it fast for me. 14 and 10 both are reduced, or can be simplified by dividing by 2. 14 divided by 2 is 7, and 10 divided by 2 is 5. And these two can be simplified by dividing both by 5. So I have 1. Divide this by 5 is 2. Okay, so I have my first equation and my second equation here. Because I have solved it for y, I can see that I have the same slope and a different y-intercept. That tells me that these two are going to be parallel. If they're parallel, they will never ever intersect, which means they are inconsistent. And then I can come down here and say parallel lines will never cross. And I can check how did I do. And the other method I can do for this is the elimination method. It's really fast here. I can multiply this entire thing by, let's say 2, so that I can compare the x's here. If I multiply all of that by 2, I'll put it down here. 2 times 7 is 14. X. 2 times negative 5 is negative 10y. And then 2 times 1 at the very end here gives me 2. And I can see that these are all matching up perfectly except this last one, which tells me that it's going to be a parallel line. And if I were to continue solving for this, if I were really doing the elimination method, I'd do negative 2, which would be negative 14, positive 10, and negative 2, and adding these two together, give ourselves an equal sign. Negative 14 and positive 14 is 0. Negative 10 and positive 10 is also 0. So on the left-hand side I have 0 equals 5, and negative 2 is positive 3. I end up with something kind of crazy. 0 equals 3, which doesn't make sense at all because 0 does not equal 3. And so I would say that there's no solution, or because these don't work, or in other words, it's inconsistent, or these are parallel. If I were to have done this elimination method, for those of you who are wanting to go this way, and those of you who don't want or didn't want to go through this, just stop and don't go any further. Those of you who are enjoying something a little bit more in depth with the elimination method, you can stay with me. If I were to end up with something true, and it doesn't matter how crazy it is, I could have 1/2 equals 1/2. I could have 7/19 equals 7/19. I could have 2 point some weird number, as long as that some weird number is the same. Whatever it is, if it is equal, I don't even know what I have in here. I just threw out some numbers. Whatever it is, if it is true, then this means that I have a that they are the same line, or that they and if I were to graph them, they would lie on top of each other, and I have infinite number of solutions. If I were to do this and get a false statement, and it doesn't matter how false, it could be something as simple as 0 equals 2, like we did here, then it's no solution. But if I were to go through the elimination method and end up with something like x equals a number, and it doesn't matter what the number is, then it's an independent system, and I can go ahead and solve it. So this is just another method, and this way you do have to memorize what you end up with as your solution. So if I end up with something crazy, it means that they are parallel and they won't ever cross. If you end up with something true, whatever it is, no matter what, then it's dependent and I have infinite number of solutions. And if I end up with an answer, well then it's the answer and it's independent.